Example, we're solving that and you guys are writing with me. Write together. I'm not gonna wait. We have lots of examples to do. First one, square root of negative 18. Can I write negative 18 in this format? Yes or no? Then, now I need two nice factors of 18. Two good factors of 18. Do not tell me 3 and 6. 9 and 2. Good job. 9 and 2. Why did I say do not use these?
Because they're not perfect.
There you go. They're not perfect squares, but this guy is perfect square, right? So that's why that's the goal. When you see a big number, if you need to simplify it, you're trying to find perfect square factors. So let me put it down here, negative 1, okay? So let's substitute the values. What was negative square root of negative 1?
I.
There you go. What is 9, root 9? So can you do anything here? You can't do anything. Here you go. This is the answer. So you can write it like that. Now look at this question. Two questions. Graph. First, we're gonna graph it. Okay, let's do that. So we do have imaginary axis and then real axis, right? X is the real, Y is the imaginary. Now, what is the real number here? Negative 5. Count negative 5. 1, 2, 3, 4, 5. And where is the imaginary portion? 1i, 2i, 3i. Okay, vertical one, in which y-axis is the imaginary. So we do that. 1i, 2i, 3i, 4i, and so on. So it's right here. So where is the intersection point? It's right there. So we graphed it. This is the graph. This is the point. Okay, you can even do this. Kind of like showing the magnitude. Okay, this is the way we graph. After then, the next question is absolute value. What was the formula? What was the formula? A plus bi. Correct. Let's match the formula and the imaginary number. Negative 5 plus 3i. So that's matches, right? A and negative 5, b and pi, 3i, they matches. And what is a? Negative 5 squared is equal to? Good. Plus b squared. Which one is b? 3 or 3i? 3 is correct. 3 squared equals 9. So that makes root 34. And the magnitude is, we have another example. So this is the standard form. So what is the real? This is the real one and then imaginary one. So 6i is here, Emmanuel, right? So where is, okay, Emmanuel, what is the real portion of this 6i? Where is the real portion? Where's a?
No A.
There's no a, so? No. The I is the imaginary. This is imaginary.
6i.
This is imaginary. What is the real portion? None. So what do you, in math, what is none means? 0. Thank you. Let's get back. Okay. Right here. 0 plus b 6i. Does that make sense? This is 6, by the way. Number 6i. Okay. So let's do that. Graph. Let's graph that real quick. We're gonna graph it real quick. So x-axis. What was the x-axis? Real or imaginary? REAL. And which one was the imaginary? Y-axis was imaginary. What is the number? 6i. 1i, 2, 3, 4, 5. 6i is here, correct? So since this is 0, the real portion is 0, it will here, and then 6 plus 6i. There you go, we just graphed it. Does that make sense?
Oh, yeah.
Yeah? Okay. Here's the
Absolute value is 36.
absolute value is 36. Are you agree? Metan said it's 36. Let's figure it out. What was the formula? Tell me the formula. Good job. So let's match the graph. 0 plus 6i. So what is A? What is A? 0 squared equals 0. What is B? 6 squared? 36. So that makes root 36. So the magnitude is 6. It's your turn to do that. If got it problem, you got it, you can solve it, right? Take your time, think about it. Alright, if you're saying A, let's check that. Let's analyze the graph. A plus BI. So real portion is 5. So real portion is 5. 1, 2, 3, 4, 5. So that makes sense when I look at that. 2, 4, 5. It should be somewhere else here, right? But they put it here, that means it's not correct. 5 here, and then imaginary portion is negative I. Negative I is just here. When I check the intersection point, it's correct. This is correct. And how did they find root 26? Square root of A squared. So what is A, ladies? A is 5. 5 squared. What is B? I is not correct. Negative 1. Negative 1 is correct. Yes. Negative 1 squared equals positive 1 root 26. It was a good example because 5 minus 1 I. This is A and this is B. I'll solve this one really quick. You know how to add like terms, correct? 4 minus 3i. Distribute the, open up the parentheses. Positive times negative equals negative. And the positive times positive is equal to positive 3i. And then we're going to add like terms. 4 minus 4, 0. 3i plus 3i. Plus minus cancels out. The result is going to be 0. Answer is 0. Next example.
What is the sum? 4 different.
Let's do. I'm gonna give you time to do that. 5. Pay attention. Sum order is the same thing. Same thing. So in this case, it's different, right? Because of the sign. We just need to distribute this sign in there. So tell me, Carlos, negative times negative 2? And how about this? Negative 4i, correct. Okay, let's do like terms. 5 and 2. 3i, 4i. You're right. 5 plus 3 is equal to 7. Negative 3, negative 4, negative 7i. We'll just distribute it. Tell me. 3i times negative 5. 3i times 2i. 6i squared, because I times I is equal to I squared. Now it's time to write another important formula. Everybody is writing that down. You can cover the another half of the paper. I squared is equal to negative 1. I squared is equal to negative 1. What was I means? I is equal to square root of negative 1, right? When you take, Metan, when you take the square root of both sides, I squared is equal to, cancels out, negative 1. So here's the formula. I squared equals negative 1. You should write it down. And we're going to substitute this. Negative 15 I plus 6. What is I squared?
Negative 1.
Negative 1. Right? So negative 15I, 6 times negative 1 is equal to negative 6. We're done, but this is not in the standard form. So it's not in A plus BI format. So I just flipped 6 and 15I. Negative 6 minus 15I. Does that make sense? We'll just FOIL it. Tell me. 4 times negative 1. Tell me, what is this? Good job. Tell me, what is this? How about this? Carlos, what is it? Negative 6 squared. Okay, good. Now, add like terms. Negative 4, 8, negative 8I minus 3I, Metan, negative. What is that equal? Correct. Okay, negative 6. Victoria, what was I squared? Negative 1. Good job. Let me write it down again. Negative 4 minus 11I. So what is this? Negative times negative? Positive 6. And we're going to add like terms. Then the result going to be 4. 6 minus 4 is equal to 2. That's it. Is that in the right format? Yes. Who's gonna tell me the answer really quick? Yes. D. C. D. A. B. B. C. It's A. What is it? Okay, let's do that. It's B. It's B. What is it? B. Okay, let's do that. 7I times 3I is equal to 7 times 3 is equal to, there you go. What was I squared? Times negative 1. 21 times negative 1 is equal to negative 21. Good job. Negative 1 to the power of 2. So what is that equal? Positive 1. Okay, if it's even, always going to be positive, like the exponent is. And let's solve this one. How we're going to solve it? We don't know what is I cubed, but we do know what is I squared. I can write this one in terms of I squared. I squared times what? I to the power of what makes I to the power of 3? I squared times I to the power of what? 1. Good job. Because when the base are saying we add exponents. Okay? 2 plus 1 equals 3. Now, you know what is I squared? Negative 1 times I to the power of 1 itself, I to the power of 1I is equal to, yes, negative 1I is correct. Because any number times 1 itself. 1 times whatever is going to be itself. Okay? So 1 times I is equal to I. So therefore, answer is going to be negative I. Okay. Now, one more example. I'm going to a little bit exaggerate and ask you guys this question. What is I to the power of 60? 1. let's check. What should I use? I need to use this key number, right? How can I write I to the power of 60 like this? What is the exponent gonna be? 2 times what makes 60? 30. Okay, 30. Then, now you guys know what is I squared? What is I squared? Negative 1 to the power of 30, correct? So, what is this equal? Negative 1 times, negative 1 times, negative 1 times, how many times? 30 times negative 1. Is equal to positive 1 or negative 1? I'm not going to write them all, right? I'm not going to do the 30 times, right? I'm not supposed to. For example, 2 of them plus 1. 2 of them plus 1. 2 of them plus 1. So 1, 2, 3, 4, 5, 6. If it's even, it's always plus, right? Because there's no leftover. If it's odd, because these are positive, this one will make everything negative. So if there is even number of itself, that makes positive. If it's odd, it will be negative. So in other words, okay, one more example. You didn't comprehend. Just give me a second. I to the power of 3. I times. Oh, wait a second. No. Wrong example. Negative 1. Okay. Negative 1 to the power of 3. Equal to negative 1, negative 1, negative 1. So result is negative times negative positive, positive times negative equals negative 1. So this is R. So let's do this. Negative 1 to the power of 4. Positive. So 2 of them are going to be positive, 2 of them are going to be positive, positive times positive, positive. So, in conclusion, if the exponent is odd, your result will be negative. If your exponent is even, your result will be positive. That's the exception. I squared. No, it's not the exception. We're talking about negative 1 powers. We're not talking about i's powers, okay? Good question, though. You will consider for a second. Now, let's finish this question now. Let's finish this question now for your question. Let's get back to our code. I to the power of 30. I is equal to I squared is equal to negative 1 to the power of 30. 30 is even. If it's even, result will be positive 1. Okay? Equation I to the power of 80. The answer is 1 correct. Because we'll write this in terms of I squared. Because why I'm doing that? Because only I know the result of I squared. I squared, I know the result. That's why I have to use it. The power of what? I squared 2 times what makes 80? Okay, now what is I squared? Negative 1 to the power of 40. Done. I'm going to write I to the power of 7 like this. I to the power of 6 times what? I to the power of what makes the power of 7? 6 plus what? 1. And the base are same. We add exponents. 6 plus 1 equals 7. Okay? Now, what is I to the power? How can I do I6? I squared power of what makes I6? 2 times what makes 6? Plus 3 times I. We're going to find this. What is I squared? Negative 1 to the power of 3 times I. So what does that equal? Exponent is, although exponent is odd, so negative 1. When the exponent is odd, it's going to be negative 1 times I. Result? Negative I. Because 1 times any number will be itself. Since it's negative, that will be negative. We're supposed to get rid of denominators from the i's. It's kind of like we're supposed to, like, if there is a negative number in the denominator, we should get rid of that. If there's a square root in the denominator, we should get rid of that. It's just something like that. We don't want i's in the denominator. For that reason, we're going to multiply. We're going to multiply numerator and denominator with the same number, which is itself, because when I multiply 3 of them, I'm going to get a whole number. Let's distribute that. Tell me, 3i times 12i. 3i times 12i, 26i squared. And then tell me what does that equal? Go ahead. 9 times 3i, 27i plus. And let's do the denominator. 3i times 3i is equal to 9i squared. So that was my goal. Like, so, well, let's do that. What is I squared? Yes, what is I squared here? Negative 1, right? 36 times negative 1 is equal to negative 36 and 27i here. So what is the denominator? Tell me what is denominator. 9 times I squared. Negative 9 is correct. And that's why we can divide everything by negative 9 now. Divide everything by negative 9. 27 divided by negative 9 is equal to negative 3i. 36 divided by negative 9 plus 4. Because negative times negative is positive. Is that in the right format? No, switch. In this question, we will, again, the same logic. We're going to try to get rid of i's from denominator. How? We will multiply that with its conjugate. We call this one conjugate. In this case, we're multiplying it. Only thing, you need to change the sign in the middle. Here's the common pitfall. Many of the students does that. Negative 1 plus 4i. Because they multiply everything by a negative, but we're not going to do that, okay? Just change the sign in the middle. Why? Because you'll see that when I distribute it, when I FOIL it, there's not going to be any I around it. Let's start. I need your help. 2 times 1 is equal to 2 times 1 is equal to 2. 2 times 4i. Correct? Tell me what is now. I'm done with 2. Now it's 3i. 3i times 1. 3i times 4i. Over. Now 1 times 1. 1 times 4i. And negative 4i times 1. Negative 4i. See, that was our goal, right? Plus minus cancels out. Did you see that? That's why I'm multiplying with the conjugate of it. And then negative 4i times positive 4i. Negative 16. Right. After that, we're going to solve like terms. Right? Those are like terms. And then let's see what's going to happen. 2, 8i plus 3i plus 12i squared. What is that? Negative 12 is right, because that is negative 1, right? So I'm going to delete this plus and then put it subtract here. Negative 16 times negative 1, that makes positive 16. Is there any question? Dale, does that make sense? Where did that negative plus work? 2 plus 8 plus 2 equals 11i plus 12i. Sorry. Yeah, I'm sorry. I'm confused, so I'm supposed to do that. I thought that I'm doing the denominator. I was looking at the denominator. Sorry, you're right. So minus 12. Good job. So now plus minus cancels out. 1 is here, correct? And then negative 16i squared. Negative 16 times negative 1 is equal to positive 16. So after then, add like terms again. So you're going to add like terms to negative 12. These are like terms. So we're adding those. And number goes first. So negative 12 plus 2, negative 10 plus 7i over 17. Is that in the standard form? A plus CI? No. So that's why I'm going to do this. I'll write these separately. Negative 10 over 17 plus, exactly, now it's in standard form, a plus I.